Alright, welcome back to this review for Chapter 9. Remember, this chapter is about solving systems, and just a little review again. What does it mean to solve a system? To solve a system means to find where two lines intersect. Sometimes they intersect in one point. Sometimes they don't intersect at all because they're parallel. And sometimes they intersect because they are the same line. They intersect everywhere. So these are the three things that can happen. And we're looking for where these lines intersect. If they don't intersect at all, we call this no solution. If they intersect in all points, because they're the same line, we say all points. And if they intersect in one point, we write an ordered pair, like 3, 5, or something like that. We write an ordered pair. And so these are the three things that can happen. I mentioned in the last video that there are three techniques for solving systems. One of them is graphing, like I just did right here. The second one is solving using substitution, and if you go back one video, you'll see that we can solve this using substitution. But today our focus is on solving systems using something called elimination. Elimination is a great technique. Let me show you when we really like to use it. Okay? Solving systems using elimination works out really good when the equations you're given are in standard form. Let me give you an example here. Here are two equations in standard form. I just made them up. And when they're in standard form, elimination tends to be a very good technique. Contrast that with the fact that if the equations, let's say I have an equation where one of the variables is almost alone, that's a better choice for substitution. Substitution. And when one variable is alone in the equation, it's better to try to solve this for y and use substitution. But with elimination, when they're in standard form, it works out great to go ahead and try using elimination. Well, let's see how that process works. All right, here's a problem that both equations, these are both lines. This is a line and this is a line, and both lines are given to us in standard form. Well, when they give us this in standard form, and we're going to solve using elimination, the best thing to do is to stack them up so that all the x terms are in the first column and the y terms are in the second column and all the constant terms are over here. By the way, you recognize that this is in standard form, ax plus by equals c. That's standard form. So when they're in standard form, the best thing to use is elimination. And so what we're going to do seems a little bit odd here now, but to solve this, we're going to try to eliminate one of these variables by doing an odd thing. What we're going to do is I'm going to draw a line here, and this line is an addition line. I'm going to add these two equations together, just like you would add, regular numbers by adding them up. And what's going to happen here is one of the variables in this equation is going to go out. Can you tell which one it's going to be? Yeah, it's going to be y, because when I add this, I got 3x and 2x, that gives me 5x, and negative 5y and positive 5y is 0y. I can write it here. I don't need to. I'm going to erase it here in a second. But that's 0y. Well, 0y is just 0, right? And 0 I don't even need to write. Right, so plussing 0 is unnecessary. So I'm just going to erase it. These two add up, and this is gone. Okay, and then we're going to add up over here, and we end up with a positive 15. Now you notice what we just did is we eliminated one of the variables, in this case y. Sometimes we'll eliminate x, but y was the one that was eliminated here. Now we can solve this equation because it only has one variable in it. So we're going to divide both sides by 5, and x is equal to 3. So what we find out is that in the ordered pair of our answer, let's put it down a little lower here, the ordered pair of our answer is going to be an xy pair 3 something. So in order to then find the y value, we're going to take this number now and stick it back in one of the equations. It doesn't really matter which one. I think I'm going to stick it in this one. Okay, x is 3, so we're going to put x in here, put in 3. So 2 times 3 plus 5 times y equals 31, or 6 plus 5y equals 31. Subtracting 6 from both sides. I'm all out of room here, and I get 5y equals 25. Yeah, 31 minus 6 is 25, and dividing by 5, we find that y is equal to 3. So my ordered pair, I'm sorry, y is equal to 5, not 3. Y is equal to 5. So my ordered pair is 3, 5. And what that says is that these two lines, if we were to graph them, they would intersect at this point, 3, 5. 1, 2, 3, 1, 2, 3, 4, 5. So I don't know where these lines are, but if we were to draw the lines, they would intersect at that point. Now that's solving a system, and we've used elimination to do that. This problem was pretty easy because the y's immediately disappeared. They're not all going to be that easy. Let's try a little harder one. All right, let's take a look at this one. Now, the instructions are going to say solve the system, and it's going to say using elimination. Okay, elimination. Well, that's why we have them stacked up in standard form. ax plus by equals c. Now, we're going to add these two equations together. So I'm going to draw a line here in a minute, but right now I look at it and go, well, you know, if I add these up, I get 14 here, and 4 here, and 28. I don't get any of the letters to go out. But I could get the letters to go out if I multiplied one of these equations. I'm going to take the top one, multiply one of these equations by a negative. Multiply by -1. And I could pick the other one, but I picked this one because its numbers were smaller. But if we multiply this top equation by a -1, I have to distribute and multiply every number times a -1. So -1 times 5 is a -5. -1 times 2 is a -2. -1 times 6 is a -6. So I just multiplied each term in that first equation by -1. Now, the good news is here, now when I draw my line to add these together, I'll end up with y going out. I end up here 9x and minus 5x is 4x. This again is 0y, 0, and this becomes 16. So dividing both sides by 4, x is equal to 4. So once again, we've used elimination to eliminate one of the variables. In this case, we eliminated y again. Again, we could have eliminated x, but this problem was much easier. You kind of have to study the problem to see what the easiest way would be to eliminate one of the variables. So if x is 4, well, then I'm going to substitute this back in one of these equations. It doesn't matter. In fact, I could even substitute it into the lower one if I wanted to. But I think I'm going to stick it into this one. 5x, I'm sorry, x is 4. So 5 times 4 plus 2 times y equals 6. And I get, subtracting 20 from both sides, 2y is equal to a -14. So y is -7. Y is a -7. Now, one of the things that is kind of really helpful is before you walk away from this problem and think you got the right answer, it would be a good idea to double check it. And I'm going to take this ordered pair and double check it by sticking it into the other equation. Let's give some room down here. So let's stick it into the other equation. 9 times 4 plus 2 times -7. Is that equal to 22? Well, let's find out. 36 minus 14. Is that equal to 22? Yes, it is. Okay. So that number, that ordered pair, does work in the other equation too. That's to verify the fact that I did this right. So here we had a little bit to do to get one of our letters to go out. Let's try another one here. All right, let's take a look at this one. Once again, this is in standard form. AX, we don't see a number here, but it's a 1, of course. If you don't see a number out in front, there's a 1 there too. AX plus BY equals C. A is 1, B is a -3, C is 7. Their standard form. Now we're going to solve this system, and we're going to add these two equations. But before I do that, I need to make sure that when I add them up, one of the terms is going to have opposites. Okay, your book talks about subtraction. I don't recommend it. Don't do it. But we're going to multiply one of these two equations again by a -1. It doesn't matter which one. I'm going to take the top one, and I'm going to take it just because I don't have to copy over one of the problems then. Let's multiply this by a -1 again. So I get -1x plus 3y equals -7. Notice I multiplied every term up here by a -1. Okay. Now I'm drawing a line telling me it's time to add. Don't draw that line until you're ready to add. Okay. So 1x and a -1x goes out. That's 0x. And 0x, of course, is 0. And 0, I don't even need to write it, right? So, and this becomes 5y. And this is 2 plus a -7. By the way, I'm just adding these top two equations. You're only going to add two equations. Don't add the one above it. 2 plus a -7 is a -5. And then we'll divide both sides by 5, and y is a -1. So my ordered pair, I know that y is a -1. So in this problem, we actually got x to go out. So we solve for y. That's okay. It doesn't matter. Whichever variable is going to be easier to go out. Now let's go ahead and stick this back into one of the equations. Again, it doesn't matter which one. I think I'll stick it in this one. Sometimes I pick it because of the size of the numbers, but x plus 2 times a -1 is equal to 2. Okay. X minus 2 equals 2. Adding 2 to both sides, we get x is 4. So we see that the x value here is 4. Now once again, there's my ordered pair. I just found where the two lines cross. Oops, -1. And so I don't know exactly where those lines are, but that's where they cross. Okay. Now I want to double check to make sure that is in fact the right ordered pair. This is my double check. So I'm going to plug that ordered pair back in the other equation. So I'm going to stick it into this one. So here we go. X is 4. Minus 3 times a -1. Is that equal to 7? Well, let's see. -3 times -1 is a +3. And that's right. 7 is equal to 7. So that checks, and that's the correct equation. Now, this is a fairly simple technique to use. This is actually part 1. And assignment number 7-3, part 1, this is about as complicated as they get. Let me give you one more problem here. All right, here's another problem. And you'll notice that it doesn't have x and y in it. It has other letters, and that doesn't really matter. I would point out, however, that usually when we write our ordered pair over here, our ordered pair is going to be in alphabetical order. So looking at the two letters M and N, L, M, N, M comes before N in the alphabet. So I'm going to expect to put M here and N here. Okay. All right, let's go ahead and solve this. Now, which variable is going to be the easiest to go out? Which variable do we have opposites or almost opposites? Well, it looks like M here, these are almost opposites. If I multiply one of these two equations by a negative, I'll get these to be opposites. I'm going to take the top one here only because I don't want to have to copy something over. And again, multiply it by a -1. -4m times a -1 is +4m. -1 times 2n is a -2n. And -1 times 6 is a -6. Now I'm double checking to make sure that I added or multiplied correctly. Negative times negative is positive. Negative times positive is negative. That's correct. Now my line indicates I'm about to add. So, by the way, some people ask, well, why does this work? Well, it does, and it seems a little bit odd that it would work, but basically, when we combine like terms in this way, when we cause variables to go out, It's just an indicator of the fact that math has some amazing properties to it. So let's add these up. That's 0m, or 0, or nothing. N plus a negative 2n is a negative 1n, and this is 2. N plus a negative 2n is a negative 1n. If I leave the answer this way, it won't work, so I've got to divide both sides by a negative 1. I have to get this variable alone. So n is a negative 2. So my ordered pair, n, is a negative 2. That's going to go over here on negative 2. Remember, the variables have to be alphabetical. Now let's take that number and stick it back into one of the equations. Doesn't really matter which one. I think I'll just stick it up in here in this one. Here we go. Negative 4m plus 2 times negative 2 equals 6. I just stuck it in there. So negative 4n minus 4 equals 6. Adding 4 to both sides. Negative 4m equals 10. And divide both sides by a negative 4. And I end up with m equals, reduce that fraction to negative 5/2. Or that's a negative 2.5 if you want to write it that way. Doesn't really matter, you can write it either way. Negative 5/2. Okay, so sometimes the answers won't come out to be whole numbers. It tells us that those two lines intersect, and where they intersect is at a place where it's not right on the grid marks. Now, I'm gonna stop this video here, and on tomorrow's video it's going to be 7-4. We're going to discuss another technique here, and then also show you what might happen if all the variables disappear tomorrow. All right, here's your homework for tonight. All right, here's your assignment for tonight. It's number 67. It's from the back of your book, page 836, lesson 7-3. Do 1 through 15 all. You can go back to the chapter 7-3, look at the examples in there if you'd like, do some more problems. But this shouldn't take you too long, but make sure you're prepared to know how to deal with elimination. All right, we'll see you on the next video where we're talking about 7-4. Take care.